Hi, this is the 2023 Junior Cert Higher Level Question 1. If you want a copy of the notes, send an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. So we're looking here at a 15-mark question, so there's a good scale. It's a strange one in that all parts A, B, and C are marked together, and that can sometimes be really good. If you get like two parts correct, then you get like the high partial, which would be 12. So, I mean, I'm just looking at the marking scheme here on the side. Now, it says here that Zena's car has a screen which shows the temperature in degrees Celsius, correct to the nearest whole number. When Zena was going to work one day, the temperatures on the screen, the temperature on the screen was 18 degrees. And part A says write down three possible values that the actual temperature could have been when Zena was going to work. So the fact that we were told that they were rounded, okay, means that like the temperature, it could have been 17.5 degrees and then rounded up to the nearest whole number, 5 and greater rounds this number up to 18. So it could have been 17.5 and just the computer rounded it up. Like, or on the other extreme, it could have been now not 18.5 because that would have rounded up to 19. It could have been 18.4. Okay. Now it could have been 4.9 and the 9 rounded and whatever. But say 18.4 would round down to 18. Or, and this wasn't actually listed on the marking scheme, but I mean, it's I don't see where it needed to be 18. It could have been 18.0, like literally on the dot. It could have been. Okay. So it could have been anywhere along that range. Now, that's the answer I put in, yeah. Now, the part B here says fill in the missing values in the inequality in T below to show the range of possible values of T when Zena was going to work. Okay, in a sense, you're using your answer in part one or part A. Now, whatever you used in part A should be accepted as fully correct in part B. And then the range here. So my biggest number was 18.4. Okay. My number here was 17.5. So like it would go from 17.5 up as far as now this is where the 18.49 would matter, but the 9 would round up to 18.5. Yeah, to 18.5. That's what I saw in the marking scheme. So you may have put in the 18.49 there. I'm not sure how loose they would have been. It's not being very explicit about what the cutoff point is there. Now the last part C says if you were to graph the actual temperature T over the course of a day, would it be more appropriate to graph T is an element of n, so a natural number, so a positive whole number. T is an element of z, so an integer, positive or negative whole number, or T is a real number, so any number. Okay, negative, positive, fraction, decimal, whatever. Give a reason for your answer. Well, we've been dealing with decimals all along, so I think just rationally you'd take that, just to make seems most logical. Okay, but if it was only natural numbers, your temperature could only be 18 or then 19 or then 20. And integer, same thing. Now it could be -1, -2, whereas a real number could be 18.4, 18.5, 18.6. So the only answer that makes sense to me there is that it's a real number. Now the reason I typed in here below, temperatures can take on any value. They can be, any number of decimal places depending on how accurate you are measuring. Not just whole numbers. So we don't just say like it's 18 degrees outside today. We might say it's 18 and a half. No, actually we wouldn't, now that I think about it. But if it was doing in science, we'd be measuring to much more higher degree of accuracy. So that's the reason. So a good 15 marks for question one. That's it for question one. So see you on question two. And if you want to copy these notes, just email shanetroy@gmail.com. Like and subscribe to get access to more playlists.